After watching this video, you'll be able to define DevOps and describe the essential characteristics of DevOps. What is this DevOps all about? One thing is for sure, it's an overused buzzword in the industry. If you ask 10 people to define DevOps, you get 11 different answers. Because of this ambiguity, let's go back to its inception and work our way forward. In 2009, Patrick Dubois coined the term development operations. He said development operations is an extension of agile development environments that aim to enhance the process of software delivery as a whole. It's an extension of agile. We're going to talk about what agile did for the devs and how it did nothing for ops. Patrick Dubois is saying, what if we applied agile to ops? What if we treat them the same? This is why sometimes I call DevOps agile for ops. This makes the ops as agile as the devs by working together for a common goal. Patrick Dubois was just saying that dev and ops can and should work together. DevOps is a recognition that development and operations must stop working in silos. They have to start working together. I like to say DevOps is the practice of development operations engineers working together during the entire development lifecycle, following lean and agile principles that allow them to deliver software in a rapid and continuous manner. I want to do it fast, I want to do it continuous, and I want to do it with dev and ops both together through the entire software lifecycle. To do that, we need to change to a culture of collaboration that values openness, trust, and transparency. We must adopt a new application design that does not require entire systems to be redeployed just to add a single function. You're not going to be able to deploy these large monolith applications 10 times a day. We need automation that accelerates and improves the consistency of application delivery so that we can deploy and deliver our software with speed and stability. Once we take that application, we split it up into lots of little microservices. No human can deploy it anymore. So we need automation to automate the deployment of all those tiny microservices. We solve some problems with applications. We create some new problems with microservices. We solve those problems with automation. Happens all the time. Finally, you need a dynamic, software-defined, programmable platform to continuously deploy onto. You can't be waiting days or weeks for somebody to provision a server and configure that server so that you could deploy your application. You have to say, I need an environment and I need it now. And you get that environment to come up, deploy your app, and your software is up and running. Now, it's important to understand what DevOps is not. DevOps is not just development ops working together. It's a cultural change. DevOps is not simply combining the dev team and the ops team and you're done. No. DevOps is not a separate team. I've seen companies make DevOps teams. It's not a separate team. If you know anything about Agile, you don't make an Agile team. You don't say, oh, we have that team over there. They're the Agile team. They make us Agile. No. Instead, the whole company becomes Agile. DevOps is not a team. It's just like Agile. And DevOps is not a tool. There are many tools that support DevOps. These tools can reinforce your DevOps culture, but they will not change your culture. You cannot become DevOps by simply buying a set of tools. And there is no one-size-fits-all strategy. This is what makes it difficult. You must find out what works for your business. Are you shipping shrink wrap software? Do you provide software as a service? Is your product or software that people download and install themselves? It'll be different based on what you're delivering, and you might not be delivering software at all. You might be delivering a service that software just enhances. So it's really important. Finally, DevOps is not just about automation. This is the one where DevOps engineer jobs come from, right? People think that if they hire somebody who knows all the DevOps tools, then that person can automate everything and make them DevOps. This is not DevOps. The devs are still doing the same thing. It's not just ops automation. That's all it is automating ops. So DevOps is not just dev and it's not just ops. It's DevOps. One word, one team, one set of measurements. In this video, you learn that DevOps is not just dev and ops working together while remaining in their separate silos. DevOps is a cultural change in which development and operations engineers work together during the entire development lifecycle. After watching this video, you'll be able to describe how applications evolve to give rise to DevOps, list the 3 dimensions of DevOps, and describe some essential characteristics of DevOps. Let's not lose sight of the goal. What is the goal? Agility is the goal. You want to be doing smart experimentation. You want to be moving in market with maximum velocity and minimum risk. This way, you can gain quick, valuable insights to consistently change the value proposition and the quality that you deliver to your customers. There are 3 pillars for agility. One of the pillars is DevOps. This includes cultural change, automated pipelines, infrastructure as code, and immutable infrastructure. The second pillar is microservices and includes loosely coupled application design using microservices that communicate via REST APIs. Microservices are designed to resist failure and tested by breaking them and failing fast. The third pillar is containers. Containers are development-centric environments that give us portability and fast startup. They also enable an ecosystem that allows quick deploys with immutable infrastructure. I like to call this the perfect storm. Taken separately, these are impressive technologies on their own, but together they enable powerful change. You have DevOps for speed and agility, microservices for small deploys, and containers for ephemeral runtimes with fast startup. Ephemeral means lasting for a very short time. They're ephemeral because when a container goes bad, we don't try and fix it. We just delete it, replace it with a new one. These are throwaway runtimes. Tony Stafford says, DevOps starts with learning how to work differently. It embraces cross-functional teams with openness, transparency, and respect as pillars. That's a tall order. Does your organization embrace openness, transparency, and respect? That's what's required to become DevOps. Let's talk about application evolution for a moment. In the past, there was waterfall with its monolithic applications deployed on physical servers, and then at some point in time, we migrated to Agile and used service-oriented architectures and virtual machines. And then DevOps followed, and now we're using microservices deployed in immutable containers. This has been an incremental evolution. We broke the monoliths into services, and the services were still large with service-oriented architecture. But we had embraced services as a design concept. Then we had virtualization in the cloud. This made things much smaller. And with DevOps, we have evolved again into microservices and containers to deploy them in. DevOps has 3 dimensions: culture, method, and tools. Most companies focus on the tools. Most vendors focus on the tools as well because that's all they can sell. Some companies also focus on methods, which are important, but the most important thing to focus on is culture. Atlassian says, culture is the #1 success factor in DevOps. Building a culture of shared responsibility, transparency, and faster feedback is the foundation of every high-performing DevOps team. If you want to be a high-performing DevOps organization, you need to change your culture. While tools and methods are important, it's culture that has the biggest impact. So, how do you change your culture? Culture is ingrained within us. It defines who we are. It includes elements such as language, our food, our values, our stories. It's extremely hard to change a culture. Countries have cultures. Companies have cultures. Many companies attempt to become DevOps, but fail to change their culture. This change must come down from the top and embrace from the bottom up in order for this change to happen. This is not an easy thing to do. So, how do you change a culture? You must change the way people think. They have to start thinking differently. You need to think about social coding and sharing. You have to change the way they work. You need to start working differently, working in small batches, using test-driven and behavior-driven development. You must change the way you're organized. A lot of companies don't get this. You must organize differently because organization has a direct impact on how you build things. Most of all, you must change the way people are measured. You must change your measurement system and measure differently because you always get what you measure. In the remainder of this course, we're going to explore the DevOps way of thinking, working, organizing, and measuring. In this video, you learn that applications evolve from waterfall development of monoliths to agile development of microservices. DevOps has 3 dimensions: culture, method, and tools. And the essential characteristics of DevOps includes cultural change, automated pipelines, infrastructure as code, microservices, containers, and immutable infrastructures. After watching this video, you'll be able to describe the problems with the waterfall method and describe the typical relationship between software development and operations prior to DevOps. It's important to understand what brought us to DevOps in order to fully appreciate the problem that it solves. Architects would spend months and months designing the system on paper, creating requirements documents, creating design documents, making high-level designs, low-level designs, system-level designs. Then, finally, we get to the development phase, where development worked for months and months on features in an isolated development environment. As they developed the code, if the designs are wrong, it was very expensive to go back to the architects. Once we developed all the code, we'd get to the testing phase, and we'd test all the code at once. And testing would open defects, send the code back to development until no more severity 1 or 2 defects were found. At some point, development would release the code to operations for deployment. This release to deployment would happen several months after the code was written, maybe even a year later. Some of these projects took up to 2 years. Then the operations team would take what seemed like forever to deploy it because they had no idea what the developers had built. And operations team kept running it from that point on. We call this way of working the waterfall method. With waterfall, everything happens in phases. Requirements are gathered, and a requirements document is generated. Then that phase ends. The artifacts for that phase flow down to the next one. In the next phase, we do all the design, and the design is documented in high-level designs, low-level designs, system-level designs, and that phase ends. Those artifacts get passed down to the next phase, and the coding begins, where developers take those low-level designs, the design documents, and write the code that implements those designs. There are entrance and exit criteria to each of the phases. So all along, we're coding in isolation. We're not integrating my module with the next person's module. Finally, you get to the integration phase when all those modules come together. This is the first time we realize we don't know whether all these pieces even work together. And then we move on to the testing phase, because now we've got a system that people can test. And as they find bugs, they must go swim back up the waterfall and open some bugs in the coding phase and do some recoding. Finally, after all that testing, we deploy the software. It's called waterfall because if there's a problem, it's very hard to go back, like trying to swim up a waterfall. You have to go all the way back to the design phase. In fact, because we treat software development like civil engineering projects, sometimes those designs have moved on, right? The architects moved on, the designers moved on to the next project, and you've got to go find them and get them to change the design. Then you get the developers to change the code in hopes that it integrates this time. This process was very error-prone, and there was no room for making changes late in the process. You didn't know whether it worked until the end, so it was very high risk. But we developed software like this for years. So what's wrong with this approach? Well, there's no provision for change. Every phase has entrance and exit criteria. When one phase ends, the next one begins. And there's just no provision for going back and changing the design or changing the requirements or anything like that. Another problem is you don't know if it works until the end. There is no intermediate delivery. Nothing is delivered until that last step when we give it to the operations team and say, go deliver the thing to production. In addition, with each phase, there are issues that are just passed down. And of course, every one of these is an opportunity to lose information and to have a mishap. People get blocked because they can't accept the work from the previous phase, and then the next phase is delayed. Mistakes that are found later are very, very costly. It's especially costly to find something that's in design wrong in the testing phase and then go all the way back and redesign it. Finally, these delays create long lead times between deliveries. Also, the overall problem with waterfall is that the teams are working separately. They're unaware of their impact on each other. Designers are unaware of the impact of the code. The coders are unaware of the impact on testing or impact on integration before we get all the code together. So everybody's working in their silos for their phase. And the scariest thought is that the people who are furthest away from the code, the poor operations team, have to deploy it and run it and manage it in production. They know the least about the code, and they're the ones expected to run it. In this video, you learn that traditional waterfall development creates problems such as delays, frustration, long lead times, expensive late changes, and operations managing unfamiliar code. And that in the past, software developers and operations worked in silos rather than working together. After watching this video, you'll be able to describe how extreme programming was the beginning of Agile and describe Agile and how it became part of DevOps. In 1996, Kent Beck came along with extreme programming. Kent based this on an iterative approach. He described these feedback loops. Release plans take months, iteration plans take weeks, acceptance plan takes days, stand-up meetings are conducted every day, and pair negotiations are done every hour, and unit testing in minutes and programming in seconds. These tighter and tighter loops represent the approach. The idea was to improve software quality and get feedback quickly, get something out to the customer, get feedback quickly, and then iterate on it. Extreme programming was intended to improve software quality and responsiveness to changing customer requirements. It emphasized concepts like pair programming. I encourage you to try pair programming. It gets two sets of eyes on every line of code and helps cross-train your team with skills. For example, a person who really knows Python will pair with one who's just learning Python. And they work together, and the junior programmer gets to see how the senior programmer approaches the problem. Pair programming is a great way of mixing the skills in your team and getting everyone under the same code to understand it at the same time. Kent Beck's extreme programming was one of the first Agile methods. In 2001, 17 software developers met in a resort in Snowbird, Utah to discuss these lightweight development methods. What they came up with is called the Agile Manifesto. The Agile Manifesto emphasized valuing individuals and interactions over process and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is to say, while this valued the items on the right, we value the items on the left more. It was a big breakthrough. People began to change their organizations to be agile. In agile development, requirements and solutions evolve through a collaborative effort of self-organizing cross-functional teams and their customers. It advocates adaptive planning, evolutionary development, and early delivery, and continual improvement. It also encourages rapid and flexible response to change. Work is done in increments called sprints. Planning is adaptive. We plan for the next 2 weeks, and then the 2 weeks after that, and then the 2 weeks after that. Agile includes continuous improvement, that is asking what you learned and what you're going to do to change. The devs were latching onto it, and I was in a couple of Agile teams back then, and it was really working out well. But being Agile doesn't solve all the problems. There are still ops to consider, and Agile was in direct opposition to the way operations was being measured. I was on a project that illustrates this concept. We started the project in January. Toward the end of February, we had code we actually wanted to deploy. We went to the ops team to deploy it, and they said, open a ticket. So we opened a ticket to get 3 VMs. And a couple days later, we asked about the VMs. It takes 20 minutes to make a VM. And the ops team said, it takes 2 weeks to find a person who has the 20 minutes to make the VM. The ticket sat, and then it was kicked back. The project was deployed in September, and I left the project in December. I couldn't take it. It was crazy that the developers were being agile, working in sprints, and then waiting for the ops team to deploy something. Agile alone is not good enough. Patrick Dubois had the realization that we need to make ops people agile. The result of this situation is called two-speed IT. Here's how it works, or rather doesn't work. A developer needs some resources. Ops tells him, submit a ticket. The developer says, never mind, I'll go to the cloud. And the developer goes to the cloud and gets the resource immediately instead of waiting for days for his IT organization or service a ticket. This is the slow speed of going through the company resources and the fast speed of getting resources outside the company. This is how shadow IT gets started. There are resources that the business doesn't know about because people go around the IT shop because IT is not meeting their needs. Then the cloud makes this very easy to do, and I would bet that every organization has users with cloud accounts and no one IT knows about. We need a solution to this problem, and DevOps is an answer. In this video, you learn that extreme programming paved the way for agile development, and Agile emphasizes valuing individuals, collaboration, responding to change, adaptive planning, early delivery, and continuous improvement. After watching this video, you'll be able to list key examples of DevOps growth that occurred from 2007 to 2019 and summarize the contributions of key influential people in the growth of DevOps. I'd like to take you through a brief history of some significant events in the early DevOps movement and point out who the key influencers were. DevOps really started in 2007 when Patrick Dubois recognized that Dev and Ops weren't working well together. He wondered if there was a better way. The next year, at the 2008 Agile Conference, Andrew Clay Schaefer created a Birds of a Feather meeting to talk about Agile infrastructure. Schaefer didn't think anybody would come, so he did not show up to his own meeting. Patrick Dubois showed up, and Patrick went to looking for Andrew because he wanted to talk about Agile infrastructure being a solution to get operations to be as agile like the developers were. This is where DevOps got started. Then in 2009, at the Velocity Conference, John Allspaw gave a talk about 10 plus deploys per day, Dev and Ops cooperation at Flickr, and the idea started gaining traction. This talk made people take notice of what was possible by adopting these early DevOps practices. Also in October 2009, Patrick Dubois, often called the father of DevOps, held the first DevOps Days conference in Ghent, Belgium. It was described as the conference that brings development and operations together. This is where the term DevOps was first used. DevOps Days is now a local conference held internationally several times a year in different cities. In 2010, Jez Humble and Dave Farley wrote the groundbreaking book called Continuous Delivery that sets out the principles and technical practices that enable rapid, incremental delivery of high-quality, valuable new functionality to users using a technique called continuous delivery. Through automation of the build, deploy, and test process, along with improved collaboration between developers, testers, operations, delivery teams can release changes in a matter of hours, sometimes even minutes, no matter the size of the project or the complexity. This book is over 10 years old, but it still has a lot of great concepts that help change a lot of people's thinking about how to perform software delivery in a continuous fashion. In 2013, Gene Kim, along with Kevin Bear and George Spafford, published The Phoenix Project, a book based on Elijah Goldratt's book, The Goal. The Goal is about a manufacturing plant that is about to go under and what they had to do to bring it back to life. It's a story about lean manufacturing principles. The Phoenix Project is about an information technology shop in a company that's about to go under and what it took to bring it back to life. This story is about applying lean manufacturing principles to software development and delivery. In 2015, Dr. Nicole Forsgren, Gene Kim, and Jez Humble founded a startup called DORA, DevOps Research and Assessment, that produced what are now the largest DevOps studies to date, called the State of DevOps Report. Nicole was the CEO and is an incredible statistician, and through this research, she found that taking an experimental approach to product development can improve your IT and organizational performance, and that high-performing organizations are decisively outperforming their lower-performing peers in terms of throughput. The research shows that undertaking a technology transformation initiative can produce sizable cost savings in any organization. If you haven't read this year's State of DevOps report, I strongly urge you to do so. The DevOps Handbook was published in 2016. It was written by Gene Kim, Jez Humble, Patrick Dubois, and John Willis as a follow-on to the Phoenix Project, and it serves as a practical guide on how to implement the concepts that were introduced in that book. John Willis, by the way, worked at Docker and Chef back then and is a DevOps Days coordinator after being at the original DevOps Days in Ghent 2009 with Patrick Dubois. If you only read one DevOps book, this is the book to read. They look at companies that have adopted DevOps and document what did work and what did not work. It's a great read. Over the past 10 years, there have been 40 DevOps Days events in 21 countries, and it's growing. Patrick Dubois was the lead for DevOps Days from its inception in 2009 until 2015, and then Bridget Krumhout became the lead in 2015. She's also a co-host on a very popular podcast, Arrested DevOps. If you don't listen to it, you should. I've learned a lot from listening to Bridget. She's heavily involved with the DevOps community. She stepped down in 2020, but stayed on the advisory board of DevOps Days, and it is a great event. I got to attend DevOps Days in New York City in March of 2020, and I loved every minute of it. These are some of the major influential people in the early DevOps movement. Patrick Dubois, Andrew Clay Schaefer, John Allspaw, Jez Humble, Gene Kim, John Willis, Bridget Krumhout, and Nicole Forsgren. They weren't the only ones, but they went out and made a difference. They showed us how DevOps can be impactful. They explained that it's all about changing culture, not just about tools. They explored measurements and the idea of changing how you work. These are the early pioneers. Why is this history important? It's important because DevOps was a grassroots effort started by people like Patrick Dubois, who just wanted to eliminate the roadblocks in software delivery and figure out how can development and operations work better together. Damon Edwards, who co-hosted a podcast with John Willis called the DevOps Cafe, said it best in his talk on the short history of DevOps way back in 2012. DevOps is from the practitioners by practitioners. It's not a product, a specification, or a job title. It's an experience-based movement that is decentralized and open to all. People were beginning to realize that DevOps was a better way to work. In this video, you learn that Patrick Dubois started the DevOps movement in 2007 with a simple idea of getting development and operations to work better together. DevOps grew through the efforts of influential people such as Patrick Dubois, Andrew Schaefer, John Allspaw, Nicole Forsgren, Bridget Krumhout, Jez Humble, Gene Kim, and John Willis.